Good day and welcome back to my training series entitled Understanding EMV. This is the 7th video in the series and we are currently in section 4, which covers the topic of EMV issuing. In this particular video, we will be focusing on EMV counters. So let's get straight into it. So what are counters? Counters are used during the day-to-day processing of transactions to keep a record of certain conditions, right? And these conditions or these records could be used by the chip when it undergoes its card risk management process. Just a caveat, the counters that are going to be discussed in this section are not comprehensive and are restricted to certain MasterCard and Visa counters only. And the thinking here is that we don't necessarily need to learn how every single counter across every single scheme or application type works. What we actually need to do is learn the underlying principle, right? And if you understand these basic principles, you can apply this principle to any counter across any scheme and across any standard. Very important point to note, please do not confuse counters with the term limits. Okay? The terms are not interchangeable. And if you're a developer or you're a techie working in the card environment and you're expected to investigate issues in production or issues on the card, it gets extremely confusing when people report issues with limits when actually what they're referring to is the unexpected values on the counter set. So please separate the two terms. In this particular section, we're focusing on counters, and we will discuss limits in one of my later videos under EMV issuing. So there are two basic types of counters. Okay, the first type is known as an incremental counter, which is fairly straightforward, right? You start from a base value and you either add upwards or you subtract down. And the second type of counter is what we refer to as a snapshot counter. And what this means is that the card will store a value of a counter in memory at a particular point in time. So think of it as a selfie, right? So at a particular point in time, an event has happened, and the card will take a picture of this, and it will use this picture to refer to, for its own calculations and risk assessment, etc. So let's have a look at some examples of these counters and how they are used. Okay, important point to note. In this section, we are going to start, delving a bit deeper into the conventions we use within EMV. And so when we talk of EMV counters, I will be using a standard way we refer to a name of a counter, the tag of the counter, and the acronym. Okay, but this principle will apply to all data elements that we store on the chip. Okay, so it's important that we understand the standard. As you progress, as you become more experienced in EMV, you'll find that it will become second nature to you. You'll find that you'll generally tend to use the acronym for the data element, and by association, that tag will eventually become mentally associated to that acronym. So the first counter, and this is the counter I believe to be the most important counter on an EMV card, is called the application transaction counter, right? So that's the name of the data element, application transaction counter. What you see in brackets next to it is the acronym. So when you're in a meeting, it gets very difficult having to call something an application transaction counter all the time. So generally in general conversation, we would just say the ATC value is equal to 43 as an example, right? And people generally understand what you are referring to when you say ATC. The last component is the tag, and this is for the ATC. The tag is 9F36. Okay, and when you write an element to a card, you generally have the tag with the associated value, right? As I said, this is probably the most important counter on the card. It is present on all cards across all schemes and standards. Okay, Your ATC is an incremental counter. The ATC is initialized to 0 during personalization, and it increments every time a chip transaction is performed. And this includes approved and declined transactions. This this incrementation will continue throughout the life of the application. So the ATC is basically a record of the number of chip transactions that the application has been used for, and it tracks it across the entire lifetime of the card. The other very important thing to note is that the ATC is never ever reset. Okay, if you have an ATC that seems to be reset, then what you're probably dealing with is an attempt at fraud. Okay. So let's sort of break it down so it becomes more understandable. Bob has received a brand new card, and the card has not yet been used. Okay, so he's opened up the credit card carrier envelope. He's taken the card out and he's stuck the card in his wallet. So in its current state, being brand new, the ATC value will be 0. Okay. Bob then goes to the shop and he basically purchases something, and that first transaction that he's performed gets routed online to the issuer. It's successfully approved. Bob removes his card from the machine, and what you'll find at the end of this transaction is that the ATC value has now incremented to 1. Bob then goes to another shop and he performs a second purchase transaction, and this time it's a low value payment. So he's bought a packet of knickknacks. The South African viewers will understand what I'm talking about, and so it's pretty cheap. It hasn't exceeded the terminal flow limits, and so the transaction approves offline. But in this case, you'll see that the ATC value has also incremented by 1. Third transaction. So Bob goes into the pastry shop next door, attempts to buy chocolate eclair, and the transaction declines for whatever reason. Let's assume that Bob was buying a lot of chocolate eclairs and the transaction needed to go online, but the terminal at that point in time was having communication difficulties. It was unable to meet the base requirement for online completion, and so therefore the transaction declined offline. Because it was a fully complete transaction, and even though it did decline, the ATC value will still increment by 1, and the value is now 3. Fourth transaction, this transaction goes online, it gets approved. Bob finally gets his chocolate eclairs, and the ATC value has now once again incremented by 1. The value is now 4. And on the 5th try, so he's gone to the shop next door, he's attempted to buy something else. The transaction has gone online, but maybe Bob has spent a bit too much, he doesn't have sufficient funds, and so his bank has declined the transaction. When the transaction is complete, the card would have updated the ATC value to 5. Okay, and just to reiterate, ATC will never ever be reset and will continue incrementing throughout the life of the card. Okay, let's move to the next counter, and this one is the last online application transaction counter. Okay, the acronym is LOATC, and the tag is 9F13. Okay, LOATC is a snapshot counter. Okay, so this counter does not increment. Rather, when a transaction has successfully completed online, the card will take a snapshot of the current ATC value and write it to the LOATC. Okay, so the base requirement for the LOATC counter to be changed is that the transaction needed to have successfully completed online. So what is implied is that any subsequent offline transactions will increment the ATC but will not change the LOATC. Okay, the base requirement is an online transaction. LOATC is present on the Visa standard, as well as the MChip 2.1 applications, which are no longer in use. MChip 4 and later, so MChip Advanced, which has replaced MChip 4, don't use LOATC. They have split the LOATC up into COTN and COTA counters, and which we will discuss. But the principle that applies to LOATC will apply to COTN and COTA. Okay. So let's have a look at how LOATC, what it actually looks like in layman's terms. So Bob's new card, once again, ATC value 0, LOATC value 0. Okay, so the first transaction has gone online. The first transaction has gone online and successfully approved, and so the ATC value has incremented by 1, so it's become 1. The LOATC value, remember the card takes a snapshot of this ATC value and it writes it to the LOATC value. And so now we have an LOATC value equals 1. Okay, Bob then processes his second transaction, and this transaction is offline. Okay, so what this means is that we are going to see the ATC value incremented 2. But because this is an offline transaction, the card doesn't take a snapshot of this, okay, because its base criteria is that it will only take a snapshot, it will only take a selfie of the last online transaction that has been processed. Okay, so the LOATC value remains at 1. Third transaction was declined, but it declined offline. So same principle, ATC will increment, but the LOATC will remain unchanged. Fourth transaction approved online. So once again, similar to the first transaction, we're seeing that the base criteria is being met here, right? So it's an online transaction. So ATC value naturally will increment to 4, but the LOATC value will also equal to 4. So the card will take a snapshot of this ATC value and write it to the LOATC. Okay. Fifth transaction went online, which is important. It declined, but it went online, but it declined because of insufficient funds, right? So Bob didn't have enough money to complete the purchase. So the ATC value will increment once again by 1, and the LOATC will also reflect that latest value of the ATC when the transaction completed online. Okay. So just to confirm, the LOATC value will be reset or it will be changed as long as issue authentication does not fail. Okay. And don't stress too much about issue authentication. We'll discuss it in a later section when you speak about OMA or ARPC validation. What this basically means is that the transaction has completed properly without an error condition, and this completion could take the form of either an approval or a decline. Okay, but the card had during the course of this transaction validated that the response that it had received from the bank was a genuine response back from a genuine issuer. Okay, let's move over to COTA, or cumulative offline transaction amount. Okay, so remember, it's a cumulative offline transaction amount. What we are counting is we are counting a monetary value, right? The acronym is COTA, and it does not have a tag. So this is one of those counters that are built in inherently into the application code itself. Okay, so COTA, or cumulative offline transaction amount, is a counter present of MCHIP 4 and higher, so MCHIP Advanced also has this, that is used for amount limit checking, right? So we are going to be adding sums of transaction amounts that we will use at a later stage to compare against a limit of some sort. Right? And remember, we're going to discuss limits at a later point. This is an incremental counter. Okay, and what this means is that we're going to start at a base value and we are going to add to it. The counter accumulates the values of consecutive offline transactions. Okay, now the important thing to remember here, we're talking about values and we're talking about consecutive offline transactions. So transactions that complete offline, one after the other. Okay, and obviously then this value will then be weighed up against the Al-Quota, U-Quota limits, which we'll discuss later on. The other important criteria to note is that this accumulation takes place using the transaction values in the card's currency. So the card is personalized with a currency. It could be rands, it could be dollars, it could be pounds. And so this quota counter will only increment on transactions that occur in the currency of the card. Right? If the transaction is not in the card's currency, it will not accumulate, and the transaction will be counted as part of the other counter, which we'll discuss later on, which is the COTN counter. Interesting thing to note is that, excuse me, this counter may be reset to 0 once a successful online transaction has been completed. Right, so let's look a bit more in detail into how quota works. Okay, so once again, we're back to the scenario of Bob getting a brand new card. At this point in time, the ATC value is 0 and the quota value is also 0. His first transaction was approved online. Okay, so remember, cumulative offline transaction amount counter counts the value in the card's currency for consecutive transactions approved offline. So this particular transaction does not meet our base criteria. Okay, this was approved online. It was 20 rand, and let's assume that 20 rand is the currency of the card. So ATC value will increment, right? Remember, online, so we're not going to count this one, and so the quota value will remain at 0. The second transaction is approved offline in the card's currency. Okay, so cards are personalized with the card currency, which is usually indicated domestic currency type, and we'll just discuss it a bit more in a later section. But for this particular transaction, the ATC value is going to increment to 2. Okay, and because it was an offline transaction and it was in the card's currency, we will now count it as part of the quota. So the quota value now goes to 20. Bob's third transaction, he performed at a merchant where the transaction was processed using a different currency. So instead of the card's currency of rands, he performed a transaction where the transaction amount was valued in US dollars. So we see that the ATC value will increment to 3, but it will be excluded from the quota value. So the quota value remains at 20. Fourth transaction gets approved offline, right? So remember this pattern we've got. So for all of these are all offline. So the fourth transaction is offline. It's in the card's currency, and it's also a transaction value of 20 rand. So the ATC value will increment to 4, and the quota value will now increase to 40. Right? Remember the 20 that we were carrying forward plus the new 20, which makes it 40. The fifth transaction is interesting because here we see we have a fifth transaction that's approved. The important thing is online. Okay, and it's a 20 rand transaction. So what this means is that the ATC value will increment to 5, but the quota value will reset to 0 because at this point in time we have gone online and this requires a reset, right? And so what will happen is the very next time Bob transacts with a card, and if it does perform an offline transaction, then the pattern will start to repeat itself. Okay. So let's move over to the cumulative offline transaction number counter, which we refer to as the COTN. Once again, no tag, as this counter is inherent to the application. Unlike the previous counter, unlike COTA, this counter counts the number of consecutive offline transactions. So this is a velocity counter. COTA is a cumulative transaction amount where we are adding the transaction amounts together. This one is the velocity counter where we're counting number of transactions. Okay, and this particular counter will be weighed up against the alcohol and UCOL limits to determine transactional behavior. And don't worry about those limits; we will discuss them in a later section. COTN is also an incremental counter, so we start at a base value and we add up. Okay, so interesting to note. I'm not going to discuss every single permutation for every single version of every single application. Just to understand that for some applications, the transactions that are counted in COTN. So for a transaction to be counted in COTN, they need to be performed in a currency that is not in the card's currency, right? So what we're looking at here is basically using COTN to count the number of consecutive offline, non-domestic or international transactions. Okay, and this count is usually reset to 0 when a successful online transaction has been completed. So let's have a look at a particular example. So the condition we need to understand for this particular card, for Bob's card, is that firstly it's a MasterCard application in the card, and the rule for this particular version of standard says that COTN may only increment for transactions where the transaction currency is not equal to the card currency. Okay, so if the card currency is rands, it means any transaction in rands won't be counted. Any transactions not in rands will be counted. Okay, in this case, let's confirm that the card currency is rands. So brand new card not used, ATC value equals 0 and the COTN value equals 0. First transaction is approved online, right? And it's a 20 rand transaction. So remember, we've got a transaction that's online and it's in the card's currency values. So it will not be included as part of the COTN check or calculation. Second transaction approved offline in the card's currency, which is 20 rand. Remember, it's in the card's currency, so we're going to exclude it. So even though the ATC value increments to the COTN value remains at 0. Third transaction approved online in a different currency. Okay, so now we're starting to see some interest. So what this means is that we are going to add this transaction to COTN. So the transaction count at this point is 1, right? So we've only met one transaction so far that completed offline, and it was in a currency different from the card's currency. The fourth transaction has approved offline, but it's in the card's currency. So the ATC value will go up to 4, but because it's in the card's currency, we will not add it to the COTN value. Fifth transaction approved. Once again, this is another offline transaction, and this one is in pounds, which is different from the card's currency of rands. And so ATC goes up to 5, and we will include this in the COTN count, and so the COTN value goes up to 2. On the sixth transaction, the transaction is routed online where it's approved. The value is 20 rand, and so the ATC increments up to 6. And what you will find at this point, at the completion of the transaction, is that the COTN value is reset to 0, and we will then repeat the pattern as we've seen above. Important point to note, offline counters are usually reset after a successful online transaction, but we could affect this, so we could change this behavior using something called card status updates or similar. And don't stress about it right now, we will be covering card status updates as part of a later section. Okay, I'm going to try to skim through the next few slides fairly quickly. So the next counter we are talking about is the consecutive transaction counter for international currency transactions, and this is the CTCI. The tag for this is DF11 within tag BF57. This works exactly the way COTN works, so this is the velocity check. It's an incremental counter. It is used to count the number of consecutive offline transactions performed by the card not in the primary currency of the card, right? So exactly the same as COTN. This particular counter is only found on Visa cards. The next counter is called the consecutive transaction counter international country, CTCIC, and the tag for this is DF51 within tag BF57. This works similar to CTCI and COTN, as discussed previously, with one difference. Instead of using the card's currency code to exclude or include transactions in the count, This counter uses the card's country code. This is an incremental counter. Generally we use country code to differentiate between domestic and international transactions. This additional differential where we're using country code instead of currency code is useful, especially for countries that have dual currencies. So typically, if you're looking at EU countries, you could have domestic transactions across multiple currency types, as the countries are still busy phasing out non-euro currency. This counter is only found on Visa cards. Next, we have the cumulative total transaction amount counter, domestic, which is CTTA, and this is tag GF11 under tag BF58. This works similarly to COTA, as discussed previously. So remember, COTA was a transaction amount counter. It's an incremental counter, and we use it to accumulate the value of offline transactions performed in the same currency as the card's currency. Okay, only found on Visa cards. The next pin is one of those very important pins that we will look at now, and we will refer to in later sections as well. Okay, so now we're looking at the pin try counter, which we commonly refer to as the PTC, and the tag for this is 9F17. This PTC, or this pin try counter 9F17, refers specifically to the offline pin, okay, specifically to the offline pin that we store on the card itself. And we will discuss pin management in much greater detail under the lifecycle management sections. But for now, just understand PTC applies to the pin and the pin management that we do on the card itself, okay, not on the backend system. This is an incremental counter, and it is set in two ways depending on the application specification. Option 1 is to set the max number of pin tries, and usually 3. And so each time the user inputs the pin incorrectly, the pin counter will decrement by 1, and when the PTC equals 0, the pin is now blocked. Okay, this is also referred to as PTC exceeded. The second method is to use the PTC in conjunction with a limit, right? And this limit is called a PTL, or pin try limit, and the tag for this is C6. And don't stress about this limit, we'll discuss it in a later section. But for the purpose of this particular section, the PTC will be set to 0 initially. And every time the user captures the pin incorrectly, we'll increment the PTC until the PTC value matches the PTL value, the limit value. Once this event occurs, okay, we then deem the pin to be blocked, or we refer to it as the PTC being exceeded. Okay, so let's have a look at this in slightly closer detail. So for a brand new card, okay, so this is for method 1, where we don't have a pin try limit loaded on a card. We have only a PTC, and so what we're going to do is we are going to set the PTC equal to the number of tries that the business or product rule for the card allows. So let's assume that the business says that this card is only allowed a maximum of 3 pin tries. Okay, so we will set the PTC value on personalization to a value of 3. So Bob transacts, and the first transaction he enters his pin correctly, and so the pin try counter is unaffected in any way. All right. On his second transaction, Bob has forgotten his pin. So he enters an incorrect pin. He enters an incorrect pin as a first attempt, and because it's incorrect, the card will identify it as being correct, and it will decrement that PTC value from 3 to 2. In the second transaction, in the same transaction, which is the second transaction, he now gets prompted to re-enter the pin, and he does so incorrectly again. And so what happens is the card will count this as an incorrect pin try, and it will decrement that pin try counter, the PTC, from 2 to 1. We're still on the same transaction, which is the second transaction. Bob is now attempting to input his pin for the third time. He gets it wrong again, right? And so what happens is the card will reduce the PTC value to 0. And what this means is that we are now in a state that is referred to as the pin being blocked, or the PTC is exceeded, right? So PTC equals 0. Okay, and look, And obviously, what the behavior thereafter, we will discuss it later on when we cover the CVM list. And the cardholder verification in terms of what types of cardholder verification would occur thereafter. But just for the purpose of this section, once the counter hits 0, we deem the card to be in a state where the PIN is blocked or where the PIN try count has been exceeded. Okay. Let's have a look at method 2. And method 2 is where we have a PTL available. So we have a PIN try limit available, and we're going to use this in conjunction with the PIN try counter. Okay. So once again, the business rule says that we will only allow a customer a maximum of 3 tries. And so at personalization, on a brand new card, we have a PIN try counter. Unlike the previous scenario, this one, we said that the PIN try counter value is set to 0. But we have a PIN try limit value equals to 3. So Bob goes, processes his first transaction, enters the correct PIN. Everything is good. PIN try limit obviously is unchanged, and the PIN try counter value also is unchanged. Okay. At this point in time, remember the PIN try counter is 0 and it's less than 3, so everything is good. The card is functioning the way it's supposed to function. On Bob's second transaction, he has a problem. Okay, so he's entered an incorrect PIN and submitted it, and what happens is the card doesn't like it, obviously, so it increases the PTZ value from 0 to 1. Okay, and it then compares this against the PIN try limit. So at this point in time, that PIN try counter value is less than the PIN try limit value. So we're still on the second transaction. Bob is being asked to input the PIN again, which he does so yet again incorrectly. And so the card flags this and says, okay, the PIN try counter now goes up to 2. It compares it to the PIN try limit and says, look, it's still less than the PIN try limit, so no worries just yet. We're still on the second transaction. We're in the third try. So basically, Bob has been requested to, on the same transaction, to re-enter the PIN, and once again he's put it in incorrectly. Okay, and so the card increases the PIN try count value to 3. Okay, and now when it compares it to the PIN try limit, we find that the PIN try counter is equal to the PIN try limit. Okay, this means that we are now in a state where the card is in a state where the PIN is blocked or the PIN try count has been exceeded. Okay, so I will share more details around PIN management in later sections, and this includes the resetting of PIN try counter and other PIN related topics. Right? We will discuss it a bit in the EMV issuing sections as well as the EMV lifecycle management sections. So it's important that we try to remember the basic concepts that we've already discussed as we hit the more advanced and the more complex sections later on. We will be referring back to the knowledge that you would have gained already during this particular video. Okay, so this brings us to the end of this particular video. Thank you so much for joining me, and I look forward to catching you guys in the next one.